The James Webb Space Telescope has been operational for less than 2 years, but it's already made some very good progress. Researchers have just revealed the full power of the James Webb Space Telescope, and you'll be shocked to discover just how powerful mankind's latest invention is. Not only that, but it might just have found life on another planet. So, just how powerful is the James Webb Space Telescope? And has it finally found life on a distant exoplanet? Get ready to discover this and much more. Since its launch in 2021, the James Webb Space Telescope has been peering out into the dark reaches of the universe, searching not only for clues on how the early universe formed, but analyzing the atmospheres of nearby exoplanets, looking for gases produced by biological life, also known as biosignatures, and chemicals that might be produced by advanced alien civilizations called technosignatures. But researchers haven't been totally sure if the telescope could really pull off these major technological feats. So just recently, they decided to test the James Webb Space Telescope on whether it could successfully detect intelligent life from the only planet that's known to be both habitable and inhabited, planet Earth. In a brand new study, researchers took a spectrum from Earth's atmosphere and deliberately watered down the data to make it look as though the telescope was looking at Earth's atmosphere from many light years away. They then created a computer model, relocating JWST's sensor capabilities to check if it was able to detect key biosignatures such as methane and oxygen that biological life on Earth produces, and technosignatures like nitrogen dioxide and chlorofluorocarbons. The results were surprising, and the research team found the altered dataset would be equivalent to the James Webb Space Telescope peering at Earth from the TRAPPIST-1 star system, which is about 40 light-years from Earth. That said, the telescope should be able to detect life, or alien civilizations, within 40 light-years of Earth, and could possibly detect signs of an extraterrestrial civilization up to 50 light-years from Earth. But a brand new and exciting discovery might just prove the telescope could see life on another planet if it was all the way across the Milky Way. They recently detected K2-18b planet is located around 120 light-years away from the solar system. The exoplanet is 8.6 times the mass of the Earth and about 2 to 3 times the size of our planet. It is a Haitian world, meaning it probably has rich amounts of hydrogen in its atmosphere and a liquid water ocean on its surface. While studying the atmosphere of K2-18b, the JWST detected carbon dioxide and methane, which is already exciting, but it's not what made this discovery tantalizing. Dimethyl sulfide, a molecule found on Earth, could also be present on this alien world. DMS is particularly interesting because here on our planet, it's only produced as a byproduct of life. On Earth, it's usually created in marine environments by a microscopic plant-like organism called phytoplankton. This makes DMS a potential biosignature, something that's never been detected on an exoplanet before. In the past, astronomers mainly considered rocky planets when searching for signs of life. However, Haitian worlds, which are hot, water-covered planets with a hydrogen atmosphere that are better suited for atmospheric observations, are now believed to be more promising as candidates for alien life. This is also because the majority of discovered exoplanets are nothing like Earth, so they may be extremely rare. Scientists aren't yet certain that K2-18b contains dimethyl sulfide. The JWST has had little time to observe the exoplanet, so we need additional data to confirm these findings. In the near future, we will find out whether substantial amounts of DMS exist on K2-18b. However, even then, we cannot be certain about the presence of life on this Haitian planet. Biosignatures are tricky for several reasons. We primarily study them based on our knowledge of the Earth's environment. Another problem is biosignatures may have various origins, not just related to living organisms. Take oxygen, for example. Even though it's produced through photosynthesis by plants and algae on our planet, it can also be purely deriving from geological or non-biological processes, like from the breakdown of minerals containing oxygen as a result of chemical reactions involving oxygen-rich compounds. What's certain is we're making progress. At first, our focus was on finding planets similar in size to Earth. Then, we expanded our criteria to include the habitability zone, allowing for the existence of liquid water. And now, we're delving even deeper into studying the chemical composition of exoplanets. Even at this stage of technological progress, we are already able to find biosignatures on alien worlds through something called atmospheric spectroscopy. All the while, scientists are discovering new ways to detect biomarkers on exoplanets. Some of these methods can potentially even describe how alien life forms existing there might look. In one study, scientists looked into the Archean eon of Earth that was inhabited by a multitude of early life forms, like purple bacteria. Several models were created to find out whether a widespread existence of such organisms would influence the way Earth appeared from a distance. Simulations involved different variables such as the abundance and distribution of bacteria, including both aquatic and terrestrial environments, as well as the presence and density of clouds in the atmosphere at the time of observation. The results of the study were thrilling. Purple bacteria have a special way of reflecting light that makes them stand out in a certain range of colors. It's similar to the red edge phenomenon observed in leafy plants, where green vegetation has a sharp increase in reflectivity in the near-infrared range. But for purple bacteria, this increase happens in a slightly different color range. This unique feature is due to the special pigment and light-absorbing properties of the bacteria. It helps them capture and use light for their energy needs. Now, given there's a lot of purple bacteria in land regions of an exoplanet and its skies aren't significantly covered with clouds, we might be able to detect the presence of such organisms using specific optical filters. The James Webb Space Telescope has certainly made many exciting new discoveries lately, but they're not the only discoveries the telescope has made this year, and the next one has created a lot of discussion and controversy. Our universe is expanding, while the attractive force of gravity pulls all matter together. In the past, physicists believed that eventually this expansion should slow down, but then we discovered that the universe's expansion is accelerating instead. It all didn't make sense if we only accounted for ordinary matter, so there has to be something else at play. That's when scientists considered the existence of the two elusive entities that prevail in the cosmos: dark matter and dark energy. Dark matter is like an invisible substance in space that helps galaxies and clusters of galaxies stick together. It constitutes 27% of the entire universe, and it's like the hidden framework that holds everything in place. While it doesn't interact with ordinary matter and emits no light, it can still be studied based on its gravitational fingerprints. Dark energy is another baffling phenomenon. It makes up about 68% of the universe and is the driving force behind the accelerating expansion of the cosmos. We know how much of it there is by examining the patterns and movements of galaxies. Even though we can't see or touch it, scientists know it's there because they've made careful measurements of things like cosmic background radiation and the universe's overall structure. Up until recently, astrophysicists had no proof of the existence of dark matter or dark energy, but this may have just changed. Stars, including our Sun, operate through a process called nuclear fusion at their cores. Nuclear fusion is when lighter elements like hydrogen are melded together to create heavier elements, primarily helium. This transformation releases an astounding amount of energy, radiating as light and heat, which is what makes stars shine brilliantly in the vast expanse of space. But there might just be another way to power stars: dark matter, or heat released in its self-annihilation, to be precise. Through the JWST Advanced Deep Extragalactic Survey, The telescope is able to observe some of the most distant regions of the universe, basically looking into the past. And since the early universe was considerably different from what it is today, truly bizarre celestial bodies formed back then, like stars thousands of times more massive than those forming nowadays. They discovered 4 stars codenamed Jade's GSZ-10, Jade's GSZ-11, Jade's GSZ-12, and Jade's GSZ-13. 2 of the 4 recently discovered stars, Jade's GSZ-12, Jade's GSZ-13, are among the most distant celestial bodies ever observed. They are stars, but not ordinary ones. According to astrophysicists, Jade's GSZ-11, 12, and 13 could be powered by dark matter, making them theoretical dark stars. Even though they're called dark, these stars are still luminous, potentially 1 billion times brighter than the Sun, and millions of times more massive. Scientists believe dark stars have been forming shortly after the Big Bang, in regions full of dark matter resulting from the collapse of helium and hydrogen clouds. In physics, there's a theory called supersymmetry, and it might explain the creation of such stars. Imagine the early universe as a cosmic kitchen where dark stars are born. These stars start cooking when clouds of helium and hydrogen, ingredients from the Big Bang, come together. Now, if dark matter particles have a special quality called supersymmetry, they can be like cosmic twins with their own super partners. Whenever these particles collide, they vanish, releasing a burst of energy, just like matter-antimatter annihilation. This energy then leads to the formation of other particles like photons, electron-positron pairs, and neutrinos. Since neutrinos hardly interact with anything, they escape the cloud, but the rest of the ingredients stay inside and interact. They slam into hydrogen and helium in the cloud, passing on their energy. This energy transfer makes the cloud heat up, kickstarting the creation of dark stars. And since such stars don't emit high-energy light, like those powered by nuclear fusion, they can remain cool for much longer, growing larger in size. Eventually, dark stars could reach a temperature surface that of our Sun, but be 1 billion times more luminous. Such stars would be up to 10 astronomical units in radius, have no core, and shine as bright as an entire galaxy of ordinary stars. Just about 200 million years after the Big Bang, there were these baby galaxies called mini-halos, which were unique in composition, mostly consisting of dark matter. These special conditions could only take place in the early universe, where there weren't any heavy elements, only the basic stuff like helium and hydrogen. So dark stars could only form in these mini-halos at the beginning of the cosmic history. This is perhaps the reason we haven't been able to observe any before. Technological progress wasn't enough to allow us to peer back in time that deep. But nowadays, we have the JWST, and things have started to take a drastic change. So how did the telescope detect these objects? When a massive galaxy passes in front of a distant star or galaxy, its gravitational field bends the path of light, a phenomenon known as gravitational lensing. This effect doesn't change the actual physical distance to the distant objects, but it distorts and magnifies the light from those objects. This allows telescopes to observe distant celestial objects with enhanced brightness, making them appear as though they were magnified or brought closer in our line of sight. But because of the unimaginable distances involved, identifying these objects as a new class of stars powered by dark matter would take much more time. At first, Jade's Z10 to 13 were thought to be galaxies, but according to computer simulations, 3 of the 4 detected celestial bodies could be hypothetical dark stars. If true, their discovery would be revolutionary and provide answers to 3 important cosmic puzzles. Previously, the James Webb Space Telescope has found an unexpectedly large number of distant galaxies that appear too massive for their age in the early universe. This contradicts our standard cosmological model, according to which smaller galaxies are forming first and then growing over time. So if some of those galaxies turn out to be dark stars, They would grow rapidly due to the energy generated by dark matter interactions, allowing them to reach supermassive sizes early on. And this might help explain why there are so many big galaxies in the early universe. Large dark stars that eventually collapsed might also explain the early universe supermassive black holes, too big to have been created out of ordinary stars that early in the cosmic history. And then there's the nature of dark matter. The existence of dark stars would confirm the existence of dark matter particles and show us proof that these particles can interact with each other in ways beyond gravity. With the help of gravitational lensing, the JWST was able to detect two other intriguing stars, Mothra and Godzilla. Both stars are located over 10 billion light-years from Earth, and both are much brighter than expected. Stars this luminous are called Kaiju stars, and they're extremely rare. Mothra is a binary supergiant star system. One of the supergiants has the brightness of 50,000 suns and a temperature of approximately 5,000 Kelvin, while the other star is a whopping 125,000 times brighter than the Sun and about 14,000 Kelvin hotter. And Godzilla is considered the brightest star ever discovered in the entire universe. The problem is, the star's luminosity is far greater than what magnification from a galaxy cluster between the Earth and the stars accounts for. Scientists are certain there is something else there, something much closer to the stars. Whatever this thing is, it has an approximate mass of 10,000 to 2.5 million times the Sun. And it can't be another star or a cluster of stars, as they would be seen by the JWST. The object or structure providing an additional magnification is invisible to the telescope, so it may be a black hole or a high concentration of dark matter, like a dwarf galaxy, almost completely made up of it. Yet another hint of the existence of dark matter. We've definitely found a lot of interesting things lately, and we've got a lot more work to do to figure out these cosmological mysteries, and it looks as though the universe is definitely going to get a lot more interesting from here on out. That's all the time we have for now, but before we go, we want to ask you, our viewers, what you think. Do you believe the James Webb Space Telescope will finally detect an alien civilization out there? And how do you think that will change life here on Earth for humans? Share your thoughts in the comments below. We hope you enjoyed the video. Stay tuned here for more fascinating discoveries of the universe and our planet. And thanks for watching.